So for your h of g of x, so we left off here. Okay, so the outside is what you are plugging it into. G of x is what you're plugging in. So if you start with your h of x, it's 3x minus 4. Okay, that's how I would start it, and then you can do your plug-in. So what you're plugging in is the g of x. So you're plugging in x over 1 minus x. Okay, and then once you plug it in, sometimes the hardest part is how do you simplify. Okay, so when you're simplifying, this is a whole number times a fraction. You're going to put it over 1. Okay, so the simplification is just 3x divided by 1 minus x minus 4. Okay, and you can leave it like that. Okay, and then we're going to do the domain. So with the domain, remember, you ask yourself these two questions. Is there a fraction? Is there an even root? If there is a fraction, we know the denominator can't be 0. Okay, so for the domain, if there's a fraction, the denominator can't be 0. So what we do is we set it equal to 0 and solve. Okay, for one like this, I would add x to both sides. Okay, so that means x can't be 1. So when you write your domain in set builder notation, it's x such that x is not equal to 1. All right, and then for part E, again, look at what's on the outside. So h is on the outside. So if h of x is 3x minus 4, you're just going to start with the function, and then instead of the x, I'm putting parentheses because that's where you're going to substitute in. Okay, so see if you can plug in that f of x, and then think about how we would simplify. Okay, so f of x is just x squared minus 1. Okay, so we're going to distribute. So we have 3x squared minus 3 minus 4. So 3x squared minus 7. Okay, and then again, you're asking yourself, is there a fraction? Is there an even root? If there's no fraction and no even root, your domain is just all real numbers. Okay, so it's x such that x is an element in the real number set. Okay, and then for f, g is on the outside. So see if you can write your function g of x without the x's in there. Okay, the good thing to do is to write in those parentheses any place you have an x. So you know where to substitute and you know where to distribute. Okay, so it's x divided by 1 minus x. Okay, and this time we're plugging in h of x. So we're plugging in 3x minus 4, 3x minus 4. Okay, the parentheses are nice because that way you can remind yourself, hey, I'm going to have to distribute here. This is 1 minus 3x minus a negative is plus 4. Okay, so the numerator is 3x minus 4. The bottom you can write two ways. You might see it as 5 minus 3x because it's negative, or you can write it as 3x minus 4 over negative 3x plus 5. Both of those are correct. Okay, so you can write them in standard form on the bottom, or like I said, sometimes if the first number is a negative, you'll see the other term first. Okay, and then we do have a fraction, so We know that the denominator can't be 0. So 5 minus 3x equals 0. And we're just going to solve that for x so we can write our domain. Okay, so I would add 3x to both sides, divide by 3. Okay, so then your domain is all values of x, except x cannot be 5/3. That would make the denominator 0, and you cannot divide by 0. Okay, so for g, we have k of h of x. And your value for k is the square root of x, okay? So when you have the square root of x, you can put your parentheses there. It is one quantity. And then when you plug in h of x, it's 3x minus 4. Whenever you have a square root, if you have a binomial or a trinomial, you are not going to be able to simplify that. Your final answer is just simply the square root of 3x minus 4. Okay, what is tricky for some people is we're so good at picking out those perfect squares, okay, that -4, we want to take the square root of it, but you can't because it's attached to that 3x. So when you're dealing with your order of operations, you would have to simplify what's in the parentheses before you could take the square root. And so you'd have to be able to add those together. There are implied parentheses when you do a square root. When you have a fraction, there's implied parentheses on the numerator and denominator. So we just have to be careful about not simplifying in those cases. Now, yesterday we talked about it was either a fraction or an even root where there was a restriction. So in the domain, if you have a square root or any even root, okay, we said that you take the radicand and you set it greater than or equal to 0. Okay, and if you have that, the radicand is greater than or equal to 0, you just take that value underneath the radical and you solve the inequality. So 3x minus 4 is greater than or equal to 0. Okay, so you're going to add 4 to both sides. You're going to divide by 3. So x has to be greater than 4/3. Yep, so when you write your domain, you're still going to write it in your set builder notation. Okay, and then I want you to go ahead and try the setup for h. And then we're going to do one more example on the back of your packet because you're going to run into this situation and I'm going to see if you guys know what to do without me. It's going to be a combination of two of our domain rules. Okay? Okay, so for your h of k of x, your h is 3x minus 4. So when you plug in the square root of x, okay, 3 times root x is just 3 root x, and then the minus 4 stays on the outside. That is your h of k of x. And then for your domain, you have to set the radicand greater than or equal to 0. Okay, so the radicand, the value underneath is just x. So the domain is x such that x is greater than or equal to 0. Okay, all right, and then the last example we're going to do is going to be on your packet. Okay, and then so we just flip to the back of your packet, please. We'll call this example I. Okay, so well, we won't call it I because that means you have the same things. I'm going to call it example 5. Okay, so in example 5, you have f of x equals 1 over x. Okay, and g of x equals 5x. Okay, we're going to find, so example 5. Okay, for example 5, f of x equals 1 over x, and g of x equals the square root of 5x. Okay, the first thing we're going to find is f of g of x, and we're going to find g of f of x. Okay, and this will help you with a couple of your homework questions today. All right, so if you have f of g of x, I want you to try to just do the first step. What is the setup? Okay, and you always want to simplify, so think about what simplifying would look like in this case. This one is a little bit harder. Okay, the plugging should be okay, it's just the simplifying. You might not be sure. Okay, so you guys are doing a really nice job with the setup. Okay, you have 1 over, and then instead of x, you guys put the square root of 5x. Okay, don't worry if you don't have the parentheses, that's fine. Now remember, if there's a radical in the denominator, how do we simplify? Yeah, you multiply, so we're going to multiply by what?
Square root of 5x.
Square root of 5x over the square root of 5x. Okay, so the reason why you have to multiply by the same thing on the numerator and denominator is because this is 1. And if you multiply something by 1, you always get that same thing. So the value doesn't change. Okay, so when you do this, you're going to get the square root of 5x over 5x. Okay, and the reason why the square root of 5x times the square root of 5x is 5x is because this is what you're doing, okay? You have the square root of 5x squared. What's the relationship between a square root and a square? They're inverses. So inverses undo the operations. That's why you're left with this. Now, when you do the domain, find domain and the composition, okay? So this is the one for the domain. I was unsure if you guys would be able to figure that out. You guys want to give it a go? Yep, that'll be part of it. Okay, so remember you're asking yourself 2 questions. The first question is there a fraction? So is there a fraction? Yes. So Okay, so if there is, then you set the denominator equal to 0 and you solve. But your second question is also going to be true. So because you have a fraction, you set the denominator equal to 0 when you solve. Okay, so x can't be 0, but you also have an even root. So you have to do both of these. So that means 5x also has to be greater than or equal to 0. Now look at what situation you have here. So x can't be 0, but x is greater than or equal to 0. How can we simplify those two together? X is greater than 0. Okay, so your domain is x such that x is greater than 0. Okay, so if both of them happen, you're going to combine these two together. Okay? All right, so let's try g of f of x. And then see if you can simplify that. Okay, so when you multiply 5 by 1 over x, remember that this is over 1. Fractions you multiply straight across. So you get 5 over x, and then you are going to simplify. Root 5 over root x. Okay, you need to break that up so that you don't have a radical in the denominator. Okay, so if you have root x, you're going to multiply by root x over root x. When you multiply a square root by a square root, they both are going to stay inside the radical. And then root x times root x is x, because this is the square root of x squared, and that simplifies. Okay, so then for your domain, again, you have two situations, right? You have a fraction, so the denominator can't be 0, which means x can't be 0. You have an even root, so your radicand has to be greater than or equal to 0. And again, you are going to end up with x is greater than or equal to 0. So when you combine those together, your domain is x such that x is just greater than 0. It would flip the sign. Yep. Okay, so I'm going to give you some time to work on this today. I'm going to give you about the next 20-ish minutes. The ones that say skip, you don't have to do. Okay, so you'll see that there's a lot of ones that you're skipping. Like on the first page, you're only doing 5 of those. Okay, and this is all about the composite functions. Okay, and then yeah, so I'm going to give you some time to work on that now.